Welcome back. It's good to see your smiling face again. How are you doing? Good. Yeah, I'm doing well. Thanks for asking. Yeah, this video is going to be on bilinear forms. The previous video was on quadratic forms. Now, bilinear forms are similar to quadratic forms, except that the square matrix is pre-multiplied by one set of weights and post-multiplied by a different set of weights. So, in the two quadratic forms examples that we did previously, which you can see in these two examples with the weights of, we got weights 111 and 132, and we found variances to be 59.9 and 133. Now in those examples, suppose that you calculate the covariance between vector TW, T sub W, and T sub V. And when we do that, it comes out to this. So you type in equals. This is what you've all been anticipating, covariance dot S for sample. We're going to highlight this first linear combination, this first vector T sub W, and then our second vector T sub V. Control Shift Enter, and we get 60.8 as the covariance. Are you excited? Cool. Well, I bet you can guess based on the colors that we're going to get the covariance here as well, but how do we do that? Well, to obtain the covariance between two weighted sums, the covariance matrix of the original variables is pre-multiplied by one of the vectors of weights and post-multiplied by the other. So we're going to have W here, 111, and 132 here. Oops. Excuse me. We're going to have 132, 13 negative 2. And our covariance, once again, just to reiterate, is our CSSCP divided by degrees of freedom, which is 6 variables minus 1 is 5. Alright, so to get the covariance using bilinear forms, pre-multiplying by one set of weights and post-multiplying by a different set, we're going to do matrix multiplication. We'll have to do it twice. So doing W, comma, C, close your parenthesis, comma, and then our vector V. Control Shift Return, and we get 60.8, which is the same that we got up there. Now we'll see later on, we'll talk about more in chapter 4 bilinear forms, but you'll see that these 111 and 13 negative 2 are corresponding to eigenvalues and eigenvectors. But we'll talk about that more in other videos. I hope you had a good day. I'll talk to you later.